So we should be right down here. We stopped here yesterday where we went over the remainder theorem, which remember just says like if you evaluate a polynomial at a specific value and you get a remainder of 0, that means that it went in perfectly, and so it would be considered a factor. And so we're going to kind of use that to help us actually start solving these equations and like trying to find all the roots that it has. All the real roots, I should say. Because if you're looking for real roots, they're going to show up like on your table. They're going to be fractions, whole numbers, decimals, those kind of things. We're not talking about necessarily imaginary numbers right now. So in order to do a problem like down here, it says find all the zeros of this equation, 15x to the third plus 4x squared minus 3x minus 2, given that negative 1 is a 0. Now, sometimes this piece here may not be provided for you. They may not always give you a guaranteed 0, and you might need to try to find one. If you need to find one, you can use your table. Do you guys all have a calculator in front of you?
No.
Okay, well, if you don't, I'd go get one. Because I want you guys on your table to plug in this function, 15x to the third plus 14x squared minus 3x minus 2. Go ahead and plug that into your table. And then I don't care where you start at, okay? I just want you to go ahead and get to your table, and I want you to look at these values. So if you guys go to your table to find a 0, if they didn't give you one, any time where a 0 shows up in the y side of your table, that x value would be considered a root. So when you guys are at your table, if you go to -1, does your table say -1, 0?
Yeah.
So that's where they're getting this number from. Now, I don't know because I don't have it in front of me. Are there other zeros on your table? If you go up and down, are you finding any other zeros?
Not on the 5%.
Okay. Okay. So there may not be other whole number zeros out there. There's probably more because remember, if this says x to the third, there's at most 3 answers that we could potentially find. And one of them is that -1. Okay. But if they don't give you a 0 to start, this is where I would begin. I would go to my table, I would type that in, and I would try to figure out where's one of the numbers that works. Okay. Because once you have a 0, we can use that synthetic division process that we did yesterday to help us get to a simpler polynomial that is easier for us to solve by factoring or using like the quadratic formula. So I'm going to set this up kind of like what we did even on our bell ringer today. If -1 is a 0, that means that if I plug -1 into my synthetic division, so don't change the sign this time. If you are guaranteed to have a 0, you keep the sign as it is. And then we grab our coefficients. What are your coefficients from that polynomial I have circled in blue? 15, 14,
-3.
yep, and
-2.
okay.
Sure.
All right, before we even begin, guys, since we know this is a 0, what should my remainder be here? Should be 0. So if we don't get a 0 at the end, we did something wrong with our math. So I need to drop the first number, 15. And then we start our process like we did yesterday. We got to multiply. So what's -1 times 15? -15. You put that underneath the 14. We add, what do we get here? -1, right? Times -1 would be 1 plus -3 times -1. So we get 0. So we did it right. Okay, we did our synthetic division correctly here. All right, now let's rewrite this as a simpler polynomial. So it'd be 15 and then x to what power? Squared, and then minus x and minus 2. Okay, no remainder. Now this is a little bit easier of a polynomial for us to try to see if we can factor it or see if we maybe want to use quadratic formula to find the other roots. I always check to see if I can factor first because factoring is faster than using quadratic formula. Quadratic formula is great because it works no matter what the situation is, but factoring is going to be a little bit quicker. When I look at this one, though, to factor it, because there's that number in front of the x squared, we have to go about that long factoring again. So let's just think if this would work. If I take a times the c, so that'd be 15 times negative 2. That'd be negative 30. And then I would want to add to a negative 1. Can I multiply two numbers and get negative 30 and add them also together and get negative 1? What are some factors of 30? 5 and negative 6. So I do think we're going to be able to factor this one. So remember when we factor these, we rewrite this. So instead of writing that negative x on the inside, we replace it with these two numbers that we just found. So I'm going to write 15x plus 5x and then my negative 6x minus 2. What do we do next?
Combine the 5x and negative 6x.
Oh, I don't think we want to combine them because then we're right back to where we were. Instead, I think we want to group so that we can try to factor. What can we take out of that first? This should be an x squared. What should we take out of the first set? 5x, and that would leave me with 3x plus 1.
Yeah.
And then what do we want to take out of the second set so that we get 3x plus 1? Negative 2. Good. Okay, so then this becomes 5x minus 2 and 3x plus 1. Now you got to think about setting these equal to 0 because I'm trying to find my roots. I'm trying to find all my solutions here. So if I set both of those equal to 0, I'm going to get fractions. That's why they didn't show up on your guys' table, because your table was set to be showing you whole numbers. Now I could go in, I could manipulate my table and have it show me all the fractions if I really wanted to, but it might not be any faster than just doing it this way. If you set those each equal to 0, what are you getting for other answers? And I think it's negative 1 over 3, right? So finally, they might want you to list out all your zeros or write out all of the roots that you found. So we have these two fractions, and what was the other one that we were given? Negative 1. So I'm going to go negative 1, negative 1/3, 2/5. I usually like to write them in order from smallest to biggest. And they would be using kind of those squiggly little brackets. Hopefully you're a little bit better about drawing them than I am. I'm not the best, but hopefully you know what I mean. That's how they would maybe write all those zeros together. Okay, let's do one last example here. Let's find all the roots here. This one also is giving you that 4 is a 0, but just remember, if they don't provide that with you or for you, then go to your table, type this equation in. You should see on your table that 4 shows up as a 0. And you could also go and look and see if you see any others. But if you do these kind of problems, I don't want you to just go to your calculator and try to find all of them all the time. Find one and then use your synthetic division process to go find the other ones. Okay? All right. So I'm going to put that 4 up in my box here. What are my coefficients for my equation? Good. And we know we should be getting a 0 for the remainder. That lets us know we did it right. Okay, so I'm going to bring down this 1. What's my next number going to be here? 4, and then you add and you get 2. 4 times 2 is 8 plus negative 9. Negative 1, and then what do we get for our last thing here? Which gives me my 0. So I know I did it right. So now I can rewrite this as 1x squared, or I'm just going to say x squared. I usually don't put a 1 in front. Plus 2x minus 1. And then we're kind of thinking about this is equal to 0. You don't have to write equal to 0, but that's really what's going on. But now we got to see, can we factor this? Are there two numbers that could multiply to a negative 1 and add to a 2? I mean, what's the only combination you can have to multiply to a negative 1? Negative 1 times 1, but if I add those, they're opposite, you get 0. So this one we can't factor. So we will probably have to use quadratic formula to finish this one off, which you guys should all remember because we just refreshed it the other day. That's the opposite of b, plus or minus, big square root sign, b squared minus 4ac, all over 2a. We got to use this formula. Okay, so let's put in our pieces. What goes in for the b term? What's my a?
1.
And my c?
1. Negative 1.
Good. All over 2 times 1. All right, let's simplify that square root. So I have negative 2 plus or minus. What's going to happen underneath the square root sign there? What is that going to become? 4, and then you got negative 4 times 1 times negative 1. That becomes positive 4. So what's 4 plus 4? 8. All over 2. We can't really square root 8. It could be simplified, though. Like your calculator can simplify the square root of 8 for you. What does it become? 2 squared root of 2. All over 2. There's a lot of 2's flying around in this problem. I think we can simplify it just a little bit. You can get rid of the whole number 2's, not the 2 underneath the square root sign. That's like the only one that's immune to being reduced because it's underneath the square root sign. It's kind of acting like a variable would be. You can't do anything with that unless there was other square roots in the problem that we were trying to get rid of as well. But all of these 2's can reduce to 1's. Okay, so this would finally be written like negative 1 plus or minus, I'm just going to write the square root of 2. I'm going to get rid of those other ones because they're just sitting in front of that square root and on the bottom of the fraction. I don't need that anymore. So there's 2 answers here. So for my final answer from all my roots, I'm going to go ahead and say negative 1 plus or minus square root of 2. And what was the other root that we were given? 4. Those are your roots. So sometimes they don't come out so nice. Like, yeah, the fractions were okay, but this one's kind of gross. And you probably wouldn't see those on your table because, again, they're going to be really weird numbers with that square root of 2 in there. They're going to be irrational. They're not going to show up on your table at all. Okay? All right. Any questions?